Recording has been resumed.
Yeah. So in notebook, we are just adding the what we can say, the APIs in the collab secrets, and according to that, we are running them. Like here, you can see the secrets which are to be added. Okay, and once the secrets are loaded, as the API is, yeah. So now comes the main part, from prototype to product. Okay, so yeah, let me zoom it so that everybody gets visible to, yeah. So why the raw notebooks break in production? So when we create a notebook, so in this logic lives in loose cells. Okay, it is in a loose cells, and also it runs in a order. So if I have to run 10th cell, then I have to run the all the cells which are before 10th one, so that the 10th cell can run smoothly. But the same thing in production is that code must run the same way every time. So if I am executing all the commands, and then I want to execute the middle one, then I can. It is not necessary that I have to start with again from the first and then comes to the middle. Okay, second thing, API keys and models hard coded in the cells. Okay, so this is also a drawback of notebook, that API keys and models, when talk about production ready agents, they are hard coded in notebook. Okay, but when comes to production ready, config comes from the environment. So we set an environment, virtual environment, in which the API keys are properly saved. Yeah. So that's the second point. Third point is the interface is you editing a cell, and in production, real users hit an API or a UI. So in notebook, you are only using this, and it just restricts to editing the cell only. You don't have any other thing like virtual environment, or we can say multiple files in just one go. So that can't be done in notebook. But in production, real users are using your product, so you will get to know more things, like what the things are coming as an error, and so on that. So in many ways, notebook fails and production ready agents wins. Okay, so yeah, in notebook, one thing, no test and no logs, your eyeball outputs. So the outputs which you are seeing is the only thing you have in notebook. Okay, but when comes to production, you can see the logs coming, you can see the test. So you get to know more things regarding your agent, that what should I need to change and what is the best thing I have, and something like that. So then comes the shape of shipped agent. So when you are shipping an agent to a production ready, so your agent logic is in like one clean class and config from environment. Okay, so your agent, like when you're defining an agent in production, so the main focus of it is answering your queries. So that should be developed in a one clean class, which is showing that everything is structured in a one class only, and all the configurations, all the env, or we can say the credentials, are coming from environment only. We don't have to set in a secrets part or something like that. And these this is first step, and when it's wrapped up, then comes the fast API part and the endpoints part. So when you're publishing your agent as production ready, it requires endpoints to when you're running your agent in production. Like as I said before, as I said, sorry for the disturbance. As I said before, Fast API is used for connecting your front end to the backend with the help of API endpoints, through which the process works smoothly. The sending the input, processing part, and coming out as the output. Okay, so yeah, and that's the whole process works with the use of Fast API, and then as we can say, the calls invoke and the same invoke. So calls invoke in the front end, where you can see, yeah, the agent is processing the output, the agent is giving the output, and in the back end you can see the tests running and the logs running simultaneously, and in the Docker you can see backend configurations. So the key idea of this is like the API is the hinge. Once your agent speaks HTTP or a UI, a test suite, and a Docker container are all just different clients of same invoke. Okay, so API is the hinge part, and once the agent starts with the Docker container, the test data, the logs, so that comes in the backend part, the same slash invoke, and the calls slash invoke comes under front end part. Now, as we move towards the refactor massive function to clean class. Okay, so here's the kind of agent code that shows up in every prototype notebook. So everybody has created a notebook in which the agent is running, or something like that. So you can see that, yeah, starting with the API key, which is hard coded in the code cells, and yeah, so and then the history is defined in a list, and when then comes to the function, so do agent stuff, and then calling the API key from the code cell itself. And also this would be making a mess also, as hard coded API keys are what we can say credentials, and that can't to be shared with anybody. So that thing notebook can't do. And yeah, so the below is the same behavior, but here we can see that uh, in notebook this type of functions are created for an agent. And when comes to the clean class, so how it becomes, so first defining the class of the agent. Okay, so what the agent is, as you can see here, the agent is a small production friendly LLM agent. Everything it needs is passed in, no globals, no hard coded secrets, no magic strings. This is the one class we reuse for entire workshop. So basically what we had done is, in notebook there is no thing like we are creating a class for our agent and defining what the role is. But when comes to the clean part, here we are defining the class agents with what they have to do, and then separate part for the API keys, the models, the system prompt, and the temperature. API key would be called from env part, and define the model, the system prompt, and the temperature. Then comes calling the API key. So we are using Grok, so that's why uh, this, and the model which we defined here. And here comes the system prompt, which we also had defined earlier regarding you are a concise, helpful agent. Okay, so we had first defined the fields, and then we are calling them from the above thing, above code, like the model, the system prompt, and the temperature, and the API is called from env. Yeah, so that we can see another function for running that. So what here we can see, send one message, get one reply, stateless and easy to test. Okay, so yeah, first I am running that, and here you can see that yeah, my code is running properly and given the output to as 200 the code. And yeah, the code is considered production ready when it is, so the code becomes production ready when it is totally tested, stable to use, scalable in any environment, and it's maintainable, and also meets the standard requirements. Like if you're creating an agent, some requirements are there, like the performance of the agent. The agent should be secure, the agent should give reliable outputs, and making it suitable for deployment to a live environment. So when comes to notebook, these parts are restricted to certain things. But in production, this has to be stated so that no errors come when the user is using your product. Now comes with the yeah, one thing, till now anyone have any doubts regarding what I had just explained now? Yeah, 1 second.
Yes, Akash, I will give you the access. Yes, Akash, you can go ahead. You have permission to unmute yourself. Thank you.
Yeah. So my doubt was in the model which you like you took the model as Llama 3.1, right? So can't we take Claude Ike or any other models if we are
Anything,
using Doc
No,
API which is
anything,
continuously up?
anything. You can take anything. See, very straightforward that I will say. You have the different cars. Okay. Uh,
Yeah.
okay. But uh, the engine is you can use any one. You're getting my point. That doesn't matter at all. So whatever the agent that you are building, that can be the different use case. So again, models is also that you can use of anyone like Claude, Gemini, okay, Grok, anything that you can able to use it. That's not a big issue at all. That makes sense. The only
Yeah.
one thing that useful, which is uh, the particular problem that you are solving and what kind of the nature of the problem or the domain of the problem, and on that particular all the parameters that you have to be used and take the decision and then use the model. Example, if you will want to go with the coding kind of the use case, then you have to take a particular model which are very good into the coding. So this is a way that you can able to make yourself and your use case dependable on the model. That makes sense?
Yeah. Got it.
Yeah. Okay,
Thank you.
Akash. Thank you.
yeah, anybody else having any doubt till now?
Yes. How is AI passed safely in the clean code? So, as mentioned by the Puneet, you don't have to be pass the API key or anything into the clean code. Okay. So that's the different way that you have to be put, like the Flask, okay, Fast API, Zango API that you have to be do. Okay. And if I talk about the API key, so API key always you have to put into the env file, and that env file will sit into the your servers. And when you will deploy your code from the GitHub to the servers, then automatically they will take the API key from that particular server where that you are going to be deploy your AI agent. Okay. Yeah. Any other questions, please? Okay. No questions. Yeah, Puneet, please go ahead, man.
Yeah, sure, sir. So yeah, now comes the fourth part, and this class from the. So we had stated that yeah, the class is totally clean, but we still passed values by hand. So when comes in production, config lives outside the code. So in environment variables or a env file, so you can change models or keys without touching source, and pydantic will reads those for us and validate types. Okay. So once we move towards the code, and yeah, here we can see that defined a class for settings, that what the settings will do. So it's basically the typed config, env files are loaded in the environment, and the grok api in the environment maps to uh, this specific variable. Okay. So yeah, now when you will what we can say, add your API key in the env file, then defining the model and system prompt and the temperature. Okay. So settings will do one thing is it will read the your API key from the environment files. So it can be any API key, like currently I am using Grok. but it's your choice. Like you can use Gemini, you can use OpenAI, or you can use any LLM API which you want in your agent to be used. It depends on working of the agent too, like what the work of your agent is. Okay, so yeah, it should be like this. The API key settings dot in the code of the agent, like the main code. Defining the agent. So starting with the API key, where it comes from settings. Second, the model coming from settings dot model, where we define these four things: the API key, the model, the system prompt, and the temperature. So once we shifted that in settings part, now we just have to call uh, the four fields with the settings. Okay, so the model, the system prompt, and the temperature all are to be called by settings file only. So yeah, once I run this, you can see that the endpoint is running properly, and I can also see here. Okay, so yeah, here we got the model, we got the temperature, and uh, yeah. So one question arises from your side is why didn't we got the system prompt and the API key? So regarding that, API key and system prompts both are what we can say credentials, and that can't be seen in any of the outputs at as that are private things to a agent and also to a company. So the API keys and the system prompts are designed and designed and used by, sorry, created by company itself, so no one wants to make them public. Okay, so that's the thing. And also we had and also settings doesn't give the API and the system prompt in the output, and that's why we only got the model and the temperature. Yeah, and moving forward, yeah, now comes wrap the agent in a fast API endpoints. So now comes the main part. As you had created your agent's clean class, here we can see that yeah, we had created the clean class of our agent. Then we had designed the proper environments, like from where to get the API keys and where to get the model, and not to print the system prompt and API keys. Okay, so yeah, now comes the fast API endpoint part. As we can see, the fast API is a hinge, as we expose the same agent over HTTP, so any client can use. So by connecting fast API, it ensures that yeah, the exact endpoint is connected to front end, so that the working is smoother and no issues can be arise during the working, as a user is currently using the chatbot. So no agent should no errors should be there while you the whole process in which it is using. Okay, and yeah, here no ngrok or tunnel is needed. The UI, the tests, and the API all share this in one virtual machine. So plain localhost just works between cells. Okay, so when you shift though your whole agent to production level, so you can also see the logs, you can also see the tests, like how my agent is working with the user's part, and is it giving any errors or something. So that part is there. And yeah, as we come with the fast API, so here you have to define the title, and version could be anything. Then comings to the invoke request, where we are giving the input. Yeah, so here we are defining class for the input, as the users will give an input to the agent, and one class is for response. So the agent will provide an output to the user based on what the query the user is giving. Okay, so we had defined two classes. One is for input and one is for output, the message and the response. Now first starting with by checking the health of our fast API, and that returns as to be the status okay. So when your fast API endpoints are running properly, then only it will give the status as okay. Otherwise, the error would came there if anything is not working in the code. Now here comes the what we can say response.model invoke response. So yeah, here's the endpoint of app.get, and here's the endpoint of app.post. Okay, so yeah, it reuses the same agent object from the step 4 which we created, that no new logic is being included in here. Yeah, and here we can see that we are uh, coming with the message, and we are returning the response. Okay, so here we have defined the class with the response as string, and here we will be returning the response from the agent. As you can see, response equals agent dot run required to be message. So the message is provided by the user, and the response is provided by the agent. Then comes the run UVCon inside collab. Okay, so as I run this, so as we can see, the API is live inside the collab and reachable from notebook cells. So one thing also, notebook doesn't like restricts here, and production ready agents does not, is in collab when you assigning the fast API endpoints and you want to see that those endpoints are working properly or not. So in notebook you can't see those, as the collab is running its own virtual environment of Google. Okay, so you can't see those endpoints when you're running in collab. And I will also like you can also see here that once I click here and it's loading, so yeah, you can see that this site can't be reached. So we can't see those endpoints running properly in collab, but when you are working production ready, so there you can also see those endpoints are working properly in the fast API docs, and you can also test them there only, that yeah, those are working properly or not. Okay, now let's run the next cell. So yeah, here we can see that we had provided an message to the agent which we defined in the above cell. Here the messages and the response. So here, yeah, give me a one line definition of an API. Okay, so this message was provided by the user, and uh, one we are printing the status so that we could get to know if any error is there. And here we are getting that yeah, the status is 200 and okay, so our agent is working properly. And here we can see the response came out from the agent. An API or application programming interface is a set of defined rules and protocols that enables different software systems to communicate and exchange data with each other. Okay, so here we are getting the response that what a one line definition of API. So yeah, the user has provided the message, the agent is responding in a correct way, and our fast API endpoint is also working properly. So here we can see that the things which we can't see in the notebook regarding the API docs, in the production ready, we can able to see those, and also we can test them to there only in the fast API docs itself. Okay, yeah. So till now, anyone having any doubts regarding how the like the fast API endpoints and how we assign that? Anyone? Okay, great. Yeah, so now we are starting with like shipping your agent. As previously we had seen like how to create the fast API endpoints, how we can connect them, and what is the difference like comes when in running in notebook and running in production level. Okay. So now the real UI that calls. Yeah. As now you can use Streamlit also, but yeah, as seeing in the collab notebook, so using Gradio, and here we can see the API URL which we are using of the here the fast API docs URL. So here we have to assign the URL, and then the UI's only job is call the API and show the reply. Here we had defined the function, the chat, the message, and the history. That job of UI is only to like call the API and show the reply. So as the user inputs the query, the backend processes the reply with the calling of the API, which gives the power to process those queries and showing the output to the user. So yeah, this runs Radio's event loop, and doing call here would freeze the UI while the model thinks. Okay, so here we can see that the demo, like which we are assigning, is the title is shipping your agent. Here's the description, like chat UI will post invoke, and then your agent class one continuous build. So this is just what you will be going to see in the Gradio interface. And one thing, Gradio provides temporary deployment. So if you are making a production ready, don't use Gradio. You can use for production ready, you can use Vercel or Render or Railway, so that your agent is deployed and users can use the product which you had developed. And do not, what we can say is, do not make sure that you do not deploy your agent using localhost, as that will only be running in your own device, and that can't be seen by anyone other. So yeah, the here it looks like that. Yeah, so we are running the Gradio part, and as we can see, here's the chatbot and explain APIs like I am 5 and write a haiku about shipping code. So as we just move towards it, so yeah, we can see it is running, and here's the output. Imagine you are at the restaurant, so it's like example of API. Yeah, so restaurant and you want a hamburger, but you can't just go into the kitchen and make it yourself. So what you do there is, you tell the waiter to just get me a hamburger, and then they go to the kitchen, then talk with the chef, and he makes it, and it brings to you via the waiter. Okay, so same example, but I will show you how the API is here. So application programming interface is like the waiter. Okay, so you are telling him what you want, as the user provide the message to the agent, is similar to the you are providing your order to the waiter, and it's a helper that takes your request, like what you want, like I want to check an error or I want some code. Okay, so yeah, that takes your request and goes to the place that you can help you, like the kitchen. And here when comes to the agent, so this will be the processing part. Okay, so yeah, the user's query goes to the endpoints, and that starts with the processing. Okay, and then in case of computers, when you use a website for an app, it's like sending a request to what we can say an example of a kitchen, and the API is like the waiter that helps us get the information you need and brings it back to you. Okay, so here's the simplest example, like how a API works when comes in a how a fast API is working when comes in a production level. Okay, so the user sends the request like his query, and the query processes by the agent, and then the output comes by the post. fast API endpoint. Okay, so yeah, and then comes the end-to-end test. So two ways to prove that the whole chain works: the UI, API, agent, LLM. So this how the user will send his request in the UI, and then comes the API part, which will take that specific endpoint and take the data to the agent. The agent will process the query of the user with the use of LLM, and then once the query is processed, then the output is came back towards the user itself. So interactive is like type a message in the radio box above and watch the reply come back. So yeah, we had given the input and we got the output regarding what the API is with a clean example so that everybody can understand. And programmatic, run the cell below, it calls the exact chat. Okay, so as we are running here, yeah, again we can see that the endpoints are working properly. The 200 code is coming here, and yeah, the okay. And shared invoke endpoint, yeah, is useful because it allows for a single entry point for invoking multiple microservices or APIs, simplifying client-side integration and reducing the number of endpoints that needed to be managed. Okay, so the basic working of a production level agent is like the UI, then comes the API, then the agent, processing done with the LLM, and then the output comes back to the user, and the user gets the desired output of what the query is. Okay, and that is a cycle repeating again and again until the user gets the final output which he or she wants, and yeah, further it can be used. So yeah, till
Sir?
now, anyone have any doubts regarding how the things are working when comes in a production level? Anyone?
Sir, your voice is not audible.
Sorry, am I audible?
Yes, you are.
Like from
Yes,
when?
yes. No issues. You go ahead. Continue.
Yeah. So yeah, then comes the Docker file. As deploying outside the notebook means handling your code to something that isn't a collab. So in collab or in a notebook, we just have to give the code and everything is running in behind. Okay, so we can't see the fast API docs or settings that yeah, my agent is working properly or not, and no, or what we can say, it's not a production ready level code that can be used by any user. So yeah, a laptop, a server, or a cloud host. The standard way is a Docker image, your code plus its dependencies frozen, so it runs identically anywhere. Yeah, the thing like the collab can't run Docker is so there is no Docker type application integrated in Collab notebook. So yeah, Docker build won't work in any of the cell. Uh, and in this step, we generate and download the files. You run Docker afterwards on your own machine, okay, or a server, producing a correct portable image. Definition is the deliverable. You don't need to run it today to have shipped it. Okay, so when you're creating production level agents, you will also be deploying that, okay, in your personal VM. So it requires the things, and as we move forward, let's run this cell, and yeah, here's the file, defining that yeah, it's a write file, not a read file. And regarding that, first importing the libraries like the fast API, the pydantic, which will import the base model, fast API will import the fast API, and settings will import the model settings, and the configuration things which we defined earlier. regarding the API key, the model, the temperature, and the system prompt. Okay, and the LLM which we are using, like I am using Grok. You can import anyone like OpenAI or Anthropic and something like that. So yeah, once the here's the class which you can see the data is in the env file. Okay, the Grok API, the model which you are using, the temperature and the system prompt. Okay, and that would be retrieved from the env file itself with the use of .env. And yeah, here's the agent class which we also had defined earlier, and it is taking the what we can say credentials like the API key, the model, the system prompt, and the temperature. So yeah, now we are running it. So the response which getting from the agent, the model which we had loaded is this, the Llama 3.3 70B versatile, and the temperature also taken from above. And the messages would be like role comes with the system, and then the content which is the system prompt. Okay, and then the role would be the user, and the content is message. So when the role is of system, the content is the system prompt, because the agent will uh, answer on the basis of system prompt only. And the role of user gives, like, the user will give the message. Okay, and we are returning the response choices in a list which will append it as the conversation goes continue. Yeah, so yeah, defining the same, the message endpoint, the message class, and the response class. And regarding the health endpoint, the app.get, and the message and the response endpoint, the app.post. Okay, so yeah, here as we also see in earlier only, the response part is coming from the agent, and the message part is going towards the agent via the user. Okay, and yeah, here's the file, the overwriting app.py. Next comes the requirements file, requirement.txt, and these files are in collab. You can see here as the Docker file and multiple files which we will be generating for further words. And yeah, so here's the requirement.txt. What we are using for the fast API, UVCon, Pydentic, the settings from which the credentials will came, and the LLM which we are using. Here is the Grok. And yeah, here we had also done with the requirement of txt, and here is the app.py file. Okay, in which the endpoints are properly stored, and what each endpoint will do, like app.get slash health is the endpoint, and it will check that yeah, the status of the agent is okay or not. Slash invoke is using for getting the message from the user, and giving the response from the agent to the user. And these are all write only files. As here we can see the write file, as we can change them. And so as the requirement.txt, and so comes the Docker file, where we are defining the Python version, the directory of the work, like where is my work stored, the requirement.txt, and what have to run, like pip install requirement.txt, and then copy the app.py, and then comes the keys passed in at runtime. And here's the command, like the cmd command, which is like uv and host, the url on which, and the port. Okay, and as we run this also, here you can see that the Docker file is created, and here we can also see that yeah, here's the Docker file we got. Okay, yeah, now we got all the three files, the app.py, requirement.txt, and the Docker file. Now we will just like the three files now live on the collabs virtual environment disk, and temporary, for a temporary time only. Once the it is closed, it will be gone. And when the runtime disconnects, then download them as a and single zip, so you can build the image on a machine that has Docker. Now all the files come in a single zip file, so that it would be easier to make it like use in any one of the um, device. And as we run this, yeah, so here we got our zip file here. And yeah, so next comes the build and run it on your own machine. Okay, so on any computer with once you have to install your Docker with like the Docker build -t, and then what the name you have to put and space and the full stop. And then comes the port, like Docker run, where we are running the port number, and your Grok API key, and the name which you had uh, so the name which you had defined earlier. Now replace your key here with your real Grok key, and the same one from setup. It's passed it and runtime, never baked into the image. The container now serves you on your machine, and you hit the exact same endpoints from step 5. So the endpoints which we created earlier, like the health endpoint, which will check the health of your agent, and second one is regarding /invoke, which is giving the outputs from the desired inputs by the user. Okay, so here we can see like the post endpoint which we created, and here's the working. And yeah, here's the application.json, and here's the message provided like hello from Docker. Okay, so basically here's the setup, like how would you set up Docker in your machine, so that you can also make your agent production ready. Okay, so now the comes with the tests and the logging part. So two production habits added onto the code you already have. One is logging. Wrap the existing agent.run so every call is traced. Yeah, like we are getting every log that runs, and what the log contains is also we can see. And the pytest, right, writes a real test file and run it, checking the health and the invoke. So what pytest uses, it will check your both endpoints, the health and the invoke, by creating a real test file and running it. Okay, so yeah, let's run that. And as we can see the output, the log check, yeah, the logs are traced. And here we can see that yeah, our agent is working properly. And the /invoke part is also working properly, the agent part. And yeah, all the logs are traced and completely running in our own machine. But the drawback is we are running in notebook, so we can't see those logs which are running simultaneously. And also the endpoints we can't test, as collab collab notebook is running on Google's VM, so we can't use that. But when you will be making your agent production ready, and there you can check the logs which are coming when someone uses your agent. And also you can check the health, and also you can test your API endpoints in the fast API doc itself. Okay, yeah. So now then comes let's run this. And here's the test agent, which will define the tests, and which will test your both endpoints, the invoke and the health. Okay, so yeah, first comes with the health endpoint. Here we can see that yeah, we are testing with the help the status code, and the status which should become when it is running properly. Okay, and same as that for the invoke part, which we are getting the response from the agent, and the messages we are sending as the user. And yeah, then comes the rejection part, like if it rejects the endpoint, like it is not working or any payload will come, then I have to show the error code of 422, and that is like bad payload. Okay, and yeah, we had also got the test-agent.py here as a file. Now we are running the tests which created by the PyTest, and it will help us run and check our agent. Okay, so yeah, here we can see that the message is going properly from the user as it returns the ping, and when comes to the API endpoints, that are also running properly. Okay, and then comes the invoke as the agent is processing the output and will provide it to the user, and that is also running properly. So all the three tests are done, and here we can see that yeah, our agent is working properly in the part of UI, in the part of fast API, in between, and in the part of backend. So all the three tests are passed, and our agent is working properly. Now next comes the request logging and version tagging. Okay, this is optional part, but if you do this, like it will help see like a small production niceties, all additive version endpoint, so you always know what's deployed, and per request logging middleware for app.py. Okay, so here we can see that the endpoint, so always know what's deployed by request logging and version tagging. If you let's say I had created an agent in which starting I had created a basic agent and something like that, and I tagged that version 1, so I know that yeah, this is my first ever agent which is going production ready. Okay, and it is running, but once the error comes, now I get to know that what things I had to change in my agent, and I have to update it. So once that update is done, I will shift my the new update with version tagging to, and that is v2, so that I should know that yeah, my version 1 was not enough able to answer all the answers or getting any error. So that's why version tagging is important when you're working in production level, so that you can know what you had changed, and what things are to be done now, so that you can't change those things by mistake that has been working correctly. And yeah, here we can see that once we are here provided the app version and one API endpoint, which we can see with the slash version part, and we are defining that function, and here we can see the name which we had defined, the version which we had set here, and this can be changed, like this is my first agent, so I am assigning the app version is 1.0.0, but if I done some changes furtherwards, I will assign the app version would be like 1.0.1, so that I get to know that yeah, I had changed in this version. And also coming to the request logging part, it will give you like let's say my agent is deployed and I am checking my logs that yeah, everything is working properly. Now as any issue arises, I have to make it clear out, and that I am tagging that version as v2. Okay, so now the request logging will do is like the logging which done in previous version will not overlap with the new versions logs, so that it will be easy to decide, and also can see that what things are working and what the issues I had fixed, so that in future versions the same mistake won't happen again. Yeah, so here we can see the name, the ship your agent, the version which we had assigned, and the model which we are using, the Llama 3.370B versatile. And yeah, for per request logging, add this middleware. So middleware is built into the app at startup, so it belongs in the file rather than bolted onto the already running server. Okay, yeah, so that's it. By working all this in your agent regarding the fast API endpoints, regarding the Docker, and regarding the tests which we done with for PyTest, and also the version tagging part. So if you include these all things which we had discussed in our today's webinar, so it would be, your agent would totally be created for a production ready agent, and you can see your fast API endpoints running properly, and if any issues you can change that. You can also see backend credentials and have to assign it in the .env file. Okay, and for deployment you can use GCP or AWS, and for starting phases like you can also go with Vercel or Render, as that provides free deployment too. And yeah, verified the full path end to end. Um, as we can see that starting with the UI part, then comes the API part, then comes with the agent, and then goes to the LLM for processing, and then back to the UI as the users can see the output. Okay, added the logging and PyTest contact tests, and also the tagging versions, so that the same mistake which we did earlier won't happen in the next deployment. Okay, yeah. So starting something is this: build your logic once, put an API in front of it, and everything else, the UI, the test, and the Docker container, becomes a client of the same endpoint. Okay, so you just have to define the logic and the API endpoints. So yeah, that's it. And here's the whole part, like from notebook to shipping your agents to production ready. And yeah, till now in the whole notebook, if anybody having any doubts, please ask now. Am I audible to everyone? Yeah. That's the whole thing which we had see, like starting with the diagnosis part, why the raw notebooks break in production, and then mapping the agent with the API and UI, so that users can send the message, the agent can process it, and the agent reply with the response as output of the desired query of the user. Then we had refactored the messy function into a clean agent class. Then we had created the pydantic settings where we stored the what APIs, system prompt, temperature, and model. And then we exposed the agent to our fast API endpoint /invoke/health, and for version that is /version. So this is the full verified path. Then packaged it into a Docker file, and added the logging part so that we can check the issues, and the tagged version finally, so that uh, what happening in each version we can see, and also won't happen those mistakes again. So yeah, that's the total flow of how you ship your agent from notebook to production ready. uh, so yeah, uh, that's it, the collab file. And yeah, now let's answer your doubts regarding the webinar and regarding the whole collab notebook, if you have any. Yeah, so now you can ask doubts for that.
I have a doubt. So,
Yeah.
like in the second point, you have said that map the agent with the API and then the UI and then the deploy flow, right?
Okay.
So, for the UI purpose, you have used Gradio library. So, but like it will be hosted in the local host itself, or like in any browser, or how is it?
Like if you are what we can say is, if you are going for a testing part, then it will be deployed in the local host, and that only used by yourself. And once it's done, you can deploy it with any of the platforms that are available, like Vercel or Render, and if you are going proper production ready, then you can also use GCP and AWS for that. But here we had used Gradio to see that deployment can be done in notebook too, but that also restricts uh, most of parts that had to be checked to make sure that agent is running properly. That's why here we had used Gradio, and also Gradio will provide the temporary deployment, like around 1 week it only provides, and for that also you have to make sure that your collab is open 24/7. Only that it will running. Otherwise, if you close, the video will also be closed.
It's the same, like similar to Streamlit, right? Like even if we use Streamlit library, like we will have to run that command in any of the code editors or IDEs. Then only that Streamlit application in the localhost URL it will be running. If we close the
Yeah.
IDE, it will be closed.
Yeah. So yeah, you can also deploy on Streamlit too. But as seen on Gradio, it will only be used in notebooks itself.
Thank you. We got it.
Okay. Yeah, you will be getting the collab notebook after the session itself, and yeah. So the code is in the collab file only. So we will be providing the collab file. So don't worry about that. No, like screen sharing is on only.
Yes, Darshan and Praveen, I give you the access to unmute yourself and ask your question. Please go ahead.
Hello.
Yeah,
Hi.
yeah, yeah.
Are you listening, sir?
Yeah. You are audible.
Yeah. Uh, since I'm a beginner of production deployment, I have one doubt. How do we even enhance this particular production deployment for scalable like Kubernetes? Adding just we have packaged this in a Docker the thing. How can we make it scalable by giving the capabilities of Kubernetes? Yeah, that is my doubt, sir. Actually, I'm not.
Praveen, I didn't get your question. Like, how you can able to do it, or you are already did it and you are facing some challenge, or still, can
No,
you just elaborate more?
no. Just as I'm a beginner, I want to know how to make it this much more production ready by making it scalable, connecting, incorporating Kubernetes. That is what, as a layman
So,
question.
like, I think so. Your question has your answer. You're getting my
Yeah.
point. So, like, what question you have? You already give the answer in your question. The scaling, yes, you have to use Docker and Kubernetes. Now, what is the question?
Well, the question is, I did not work upon a hands-on experience in Kubernetes. That's what.
So that's, I think that's not our job role. Okay, that's the comes under the DevOps teams or MLOps team of the company. If you are working in a company, then they are the proper separate team who work in the MLOps part or DevOps part, who will take care of your development of the AI agent, and they will put into the Kubernetes, Docker, and everything. And if you are working in a company where that your like you don't have the proper dedicated team, in that case that you have to put it everything into the Docker, then multiple containers will be run based on the scaling part, and then Kubernetes is going to be handle it. That's it.
Well, fine, sir. And one more question, if you don't mind,
Please.
yeah, what is the difference between ECS and EKS instance? These words are very confusing as a beginner layman terms.
I can understand. Please go ahead.
Yeah, what is the difference between ECS, EKS, and what is the instance and all this kind of technical
Actually,
jargon?
this is related to the cloud part. So EKS, GKS, all this services.
ECS, sir. ECS, EC2 instance something.
So EC2 is a kind of the instances available on the AWS part. Okay. So whenever you will put the any kind of the server on the AWS, then known as the ECS. Take an example like if you will eat vada pav in Mumbai, then it's called as a vada pav. If you will eat vada pav in the US, it will call as a burger. So both are same.
Oh, okay. Just terminology.
Terminologies. You are Praveen here, but you will be named as a Pintu or any other your nickname, but you are the single person. You're getting my point.
Got the point, sir.
So yes. So every company is giving the different kinds of the terminologies to making the things based on that. Okay.
Okay, fine, sir. Fine, sir.
Okay, Praveen. Nice to talk to you, man. Yes, Darshan. Yes, Darshan. Please go ahead.
Yes, Darshan.
Okay, Bhanu Prakash, we gave you the access. Please go ahead if you want to ask something.
Like we have to build this to production scale, so we have to do it in local machine or how to set up these things. Like I don't get it the
So
overall.
first you have to do everything on the local machine. Then you have to set up a Docker and map a Docker file, and then put it into the any server, either GCP, AWS, or Microsoft.
Okay, then how to submit it? Like just submit the project file to the in website.
So that's already given. I will send you a link. So step by step is given. Still, if you have any doubts, then any doubts, then we are happy to answer you. Okay, here's the link that you can able to give the submissions.
So what I get is now like we have to build everything in our laptop, like a device, anything, and then we have to build it like production ready. So we have to use Docker and everything, so that
No. Whatever that you have been built, you have to just submit. That's it. No other thing. Okay.
Can you repeat again? Come again.
Yeah. So I'm saying whatever that you have been built doesn't matter. It's production ready or not. We have to just see how well that you have been done in the development. That's it.
Okay.
Okay. Okay, everyone. It's nice to talk to you, everyone here. So soon we will share you everything on the email, proper recording, resources, how you can able to submit your agent for the AI agent builder series, and we'll meet you in the next session as well. Thank you so much, Puneet, for your insightful session and detailed explanation of everything. Hope everyone like it and enjoy it. Appreciate your efforts. So bye everyone. Take care. Good night. Meet you soon. And stay available on the email. We're going to be send proper email detail. Okay. Bye. Take care.